Hi everyone. Today we're going to talk again about trigonometric ratios, but this time we're going to talk about what happens if we have the sides and we want to find a missing angle. So we've already talked about if we have the angle and a side and want to find the other side, we're going to set up an equation and we're going to solve using algebra to find a missing side. We're going to do something very similar today to find a missing angle. We're going to set up an equation, but then we're going to have to use inverse trigonometry. So when we're given an angle and we want to find the side, we use trig. And when we are given the multiple sides and we want to find an angle, we use inverse trig. So a few helpful rules similar to last time. Always draw the picture, label it. We have the opposite, the adjacent, the hypotenuse. This time we're going to have two sides. We're then going to write an equation. And if we want to find a side, we use trigonometry. So we use sine, cosine, or tangent. When we want to find an angle, we use inverse trig. That's the sign with raised to the negative first power. It's called the inverse sign. Cosine to negative first, inverse cosine, or we could use inverse tangent as well, depending on what sides we're given. Here's the problem we're going to analyze, set up an equation for, and solve. Always has to be a ladder problem. For the last 30 years, I've seen my fair share of ladder problems where they ask you to find the angle that the ladder makes with the ground to check if the ladder is safe. They tell us the ladder is 3 feet away from the wall, and then the length of the ladder is 16 feet, and they want us to find this angle. So we have the picture, but it's not labeled with the opposite, the adjacent, and the hypotenuse. So let's go ahead and do that. I see opposite, adjacent, hypotenuse, and the two sides that I'm given are the adjacent and the hypotenuse. So we need to think about which trig ratio has adjacent and hypotenuse, and that ratio is cosine. So we set up the cosine of this angle is 3 divided by 16. Now we can spend all day guessing the angle that gives us 3 over 16, or we can think about how can we solve this. Now we can't multiply by 16 and move it over to the other side. We want cosine of theta by itself. More importantly, we want to get theta by itself. So what we're going to do is we're going to take the inverse cosine, which is going to undo cosine. And whatever we do to one side, we have to do to the other. So we need to take the inverse cosine of both sides. Now on the left side here of the equation, inverse cosine and cosine are just going to cancel out. So the left side is just going to wind up being theta. And the right side, we can use our calculator to evaluate. The right side is saying, what angle can we take the cosine of that gets us 3 over 16? So the inverse cosine of 3 over 16 tells us the angle should be 79.19 degrees. To check that, if I would like, I can do the cosine of 79.19 degrees, and I get a decimal, which is approximately 3 over 16, which is what I wanted. So this angle right here is 79.19 degrees. So I set up a trigonometric equation, and since it wanted an angle, I used inverse trig, so I used inverse cosine, and that's how I find an angle.